stars are so far away. The nearest one is about 150 million kilometers away from us, I mean our sun. But it's too hot to land on. It doesn't mean we can't study it and know what it is made of. In this video, I will explain how scientists know what the outside of the sun is made of. First of all, let's talk about atoms, the basic units of matter. As you may know, each atom is made up of three particles: protons and neutrons, which make up the nucleus, its center, and electrons, which surround it in a kind of cloud of orbitals in different levels of energy. These electrons can move or jump from an orbital to another one when they gain or lose energy. So they can move or jump. Well, it's a little bit more complicated than this. They disappear and reappear. From the ground state, the lowest energy state, to an excited one where the level of energy is higher, and this can be done using heat or light. So we are talking about an excited atom. It means not all the electrons are in the lowest possible energy levels. But wait, how this can tell us what stars are made of? Let's forget about atoms and talk about Newton's experiment. In 1665, Newton passed one beam of sunlight through a glass prism, then he saw a rainbow. It means that white light, yes, because sunlight is white, is a mixture of all visible colors. We are talking about a spectrum. So years after this famous experiment, scientists have discovered that there are some black lines in the sun spectrum. And by using a spectrometer, by the way, spectrometer is a scientific instrument used to split light into separate colors much better than the glass prism. And by using it, they saw a lot of these dark lines. The question is what they are. The answer is maybe in your minds. So they can move or jump from the ground state, the lowest energy state, to an excited one where the level of energy is higher, and this can be done using heat or light. In fact, these are not black lines, they are colors which are missing from the spectrum because they were absorbed. Some particles were there, I mean in and around the sun, and each one have absorbed a specific wavelength that corresponds to moving the electron from a state to another one. On the other hand, when the electron falls back from an excited state, the energy gets emitted as light. So scientists have done a lot of experiments to know which colors each atom emits, and finally they've known what it absorbs. For example, hydrogen emits the colors above, as you can see in the first spectrum. When these same specific colors are missing from the sun spectrum, we can say that hydrogen is there. That's how scientists know what the outside of the sun is made of. Light helps astronomers to study the distant planets, stars, and galaxies, so it helps us to study our universe.